The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, welcome back to another episode of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project, and joining us today is my lovely co-host and partner, Leah Shaper.
Hello.
Welcome to the show. A lot of people imagine you co-hosting the show in the trailer there. I read that in the comment.
I'm not in the trailer. I'm at in our house.
Yes. Yeah. All right, we got a great show. We're going to be talking about a dangerous developing hurricane in the Gulf. It was just named about 5 minutes ago, Tropical Storm Milton, and where it's headed. We're going to be talking about the X7 Milton.
I don't know why that's funny. It sounds so demure for her hurricane.
Well, Milton could be a very severe hurricane and be very severe. So we'll get to that in a second.
Which makes it even funnier.
We're going to be talking about the two X flares that just popped off the sun in the last 3 days, an X7.1 and an X9.05. It appears as if the X7 flare has completely missed us, which is good news for Earth and bad news for aurora watchers last night that thought the skies were going to light up, and in fact, they did not.
Well, maybe the flare didn't miss us, but the CME did miss us.
Yes, the CME from the flare.
Yes.
So in the final half of the show, we're going to be talking about a press release that came out yesterday where scientists claim that they have discovered 2 billion-year-old life inside of a rock of the same age. Absolutely mind-boggling, because the oldest known microbes that we have that are alive in a rock up to this point is about 100 million years old, and these babies eclipse that 20-fold. So
well, even 100 million-year-old microbes is pretty freaking impressive. So when we get to 2 billion, obviously that is also extremely impressive.
And what's also impressive is that this is not part of the fake Pacific Ocean, which supposedly existed. But it is 2 billion years old. And let's dive into it. You got any questions?
No.
All right. For those listening that live in Florida, buckle up, because you've got a major storm that is headed your way, and its name is Milton.
Its name is Milton. Watch out for Milton, everybody.
Yeah, Tropical Storm Milton was just named a few moments ago. It will be Hurricane Milton in a matter of hours, in my opinion. Let's look at the current tracks that are coming from the National Hurricane Center. They have a large cone here. See, Florida? Mm-hmm. In their models, it could hit anywhere from Miami all the way up to the Gulf Coast and the Panhandle. It is going to hit as a major hurricane. We can come over and look at some of the spaghetti models, and you can see that the majority of them are lining up near Tampa Bay or south, Central Florida. And there's only one that moves in a southerly path. It's the European model that's creating this southern path, and the GFS and other runs are creating these. In another 24 hours, there should be a solid path on this storm. But the bad news is the rainfall potential, not the actual hurricane. Those on the coast, if it does get to Cat 3 or 4, will have the brunt of the damage on the coast. But it will be 24 hours later, when 20 inches of rain falls across Florida, that everyone that's living near a river will be flooded.
Yikes.
And people really don't get that about the flooding. I think they woke up to flooding and hurricanes once again. Like they have amnesia. They don't remember Hurricane Floyd in '89, which flooded the Schuylkill River in all of Philadelphia.
Yeah.
And other hurricanes that cause major flooding, which is the major factor in displacing humans.
Yeah. That does seem to definitely be the case, right? It's not necessarily the winds, it's excessive rainfall and flooding. In other words, it doesn't matter if you're at sea level or in the mountains. If there's a river near you, you are in danger.
Or if there's not even a river near you and 20 inches of rain falls, if you have a valley that doesn't have a creek in it, it is going to have a creek in it.
Yeah.
And so that is the reality.
Yeah.
So let's take a quick look at the intensity models that were probably just updated as Invest 96 became Tropical Storm Milton just moments ago. The intensity forecasts look horrible because it's looking like landfall will be Wednesday. So that is Saturday, Sunday, Monday, Tuesday. That is 5 days from now. And if we go out 5 days from now, some of the models are showing this above Cat 4. The majority are placing it as strong Cat 2 and Cat 3. Here is the scale on the side. And so this is going to be a strong storm.
What's the unit KT for intensity?
Oh, that's knots.
Knots. Okay.
Yeah, so wind speed is up here on the side.
Wind speed. Okay.
And so this is going to be a strong storm. And I hope everyone is ready. If it shifts to the north, so this is the GFS run that just came out, the 12Z. If it goes along this track, this is going to hit the same areas that Hurricane Helene hit. They're still cleaning up in Tampa Bay. And then it's going to move across Florida here, and there will be massive flooding from this event. Let's take a look at the total accumulated precipitation. You can see that yellow line, yellow bad. Yellow is 12 inches or more, 12 to 20 inches along that strip. And it also looks like there could be some flooding in the Fort Myers area. And earlier on, this is a two-phase storm. There is some rain that's going to be happening over the next 3 days. Do you see it accumulating there? And then this is the hurricane behind coming through on Wednesday.
Isn't that yellow actually 24 inches? Is the scale on the right in inches? I can't see the whole thing.
Well, actually, you're looking at, so the bright yellow now in this spot is 20 inches, just the center, and then it drops down to 16 here.
Yeah.
And the orangish is 10 to 12.
Yeah, okay.
These models are going to change, but they've been lining up for 2 days, and I've been warning people on our daily updates about this. So this is a very serious storm.
This is just what the Southeast needs, right? Like,
take the necessary precautions. Okay. Do you have any other comments on that? Let's run I'll show you the European model. It only is going to go out a few days. So in the European model here, we can see the tropical storm, which is already formed there in the Gulf as it slowly makes its way. And this is a more southerly path that will take it more towards Fort Myers and Naples on that model. But we're going to have a much better outlook on this tomorrow. So start preparing for the worst and take these models with a grain of salt right now, because they will change slightly, because the cone of uncertainty is all the way from Miami all the way up to the Panhandle.
You know, what's especially scary about this for folks in the Southeast who already endured Hurricane Helene and are dealing with the aftermath of that, like, let's say this takes the more northerly track, it's quite possible that a lot of those people don't really even have good communication to know much about this coming.
Yeah, well, the cleanup in Florida is much faster and more advanced than the North Carolina area. So that's good news. A lot of the cleanup is already occurring. The power is all on in Florida. It is not in North Carolina or South Carolina. Well, that's what
I'm thinking. I'm thinking more about North Carolina than anything. Yeah.
So there is still power out. So if this shifts up into this direction, there's no evidence that it's going to go up there. This is probably the track. This is the track that's been showing up for the last 2 days on and off, right through Central Florida. So our prayers up all those affected. Now let's talk about the solar storm that couldn't. So these sunspots down here were blasting out those X flares. They're now facing away from Earth. We do have a big sunspot that is coming into play right now as well, but not any flaring out of that currently. So that's good news that we don't have any flaring coming from that. But the 3-day geomagnetic forecast has been changed continuously. Yesterday, it showed G3 geomagnetic storm for the 4th and the 5th, and that has been canceled. So as you can see here on telemetry, let's refresh it. There has been, if this is probably the arrival of that X7, just this spike.
Yeah.
And it did absolutely nothing. And possibly because of the way the magnetic fields were, it pushed the BZ to the north. And that's not how we get geomagnetic storms. We get the storms when the BZ pushes south. And we could see it's pushing south right now in the last 4 or 5 hours. This is because of the approaching X9 flare that's coming.
Yeah.
And when that comes, this should probably hit the floor.
Yeah.
And then we'll see a spike in density and speed. The speed is so low. We're at 400 kilometers per second. I can barely see this getting at 600 or higher. So G3 is a pretty good call for this solar storm.
Yeah.
And they're only showing a spike tonight into tomorrow morning where we could be in G2 geomagnetic storm for, it appears, 12 hours, and G1 geomagnetic storm for the next 2 days.
And the aurora forecast also was tremendously downgraded, wasn't it? Or maybe not.
Well, tonight's and tomorrow's is still here. The other forecasts were completely wrong.
Yeah.
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 Yeah, so they do get it completely wrong.
Yeah.
Like they just did. There's no chance that there's going to be any infrastructure problems or the end of the earth with this solar storm. This is simply for aurora watchers. And because of our weakened magnetosphere, this aurora line is usually incorrect. When they say—
I've noticed that.
Yeah, the view line is usually down here near Texas.
Yeah, like more recently, let's say during the solar storms in, what was that, May?
Yeah, the May superstorm, that was Mother's Day.
Oh, right. I think as I recall, the aurora forecast didn't come that far south, but we could actually see it here in Colorado, southern Colorado.
Yeah, and that has to do with the weakening magnetosphere and the fact that I don't think NASA and NOAA are accounting for it in their models.
Well, that's what I was going to say. I don't think that the calculations involved with this prediction include the context of the weakened magnetosphere. So they need to adjust their calculations, clearly.
Right. So probably tonight when this replays, we will be in geomagnetic storm. And that is on.
and tonight it probably won't affect our show, which is nice.
Right. And that's on Magnetic Reversal News on YouTube at 8 p.m.
Mountain time.
Yep. All right. So how does this X9 flare compare with the last solar cycles? Is solar cycle 25 outperforming solar cycle 24? Not yet. Solar cycle 24's largest flare was an X13.3, and the second largest flare was an X11.8, and the third largest was an X9.9, which is basically an X10, and then the fourth largest was an X7.8 or an X8. So there are 3 flares larger than this flare in cycle 24. And we still have some solar max to go, so we may get a larger flare.
Yeah. Yeah. I was actually just looking today at the solar cycle, the last 5 solar cycles, comparing the magnitudes and the shape of the curve. And, our solar max for solar cycle 25 is higher than solar cycle 24 was, but significantly less than solar cycle 21, 22, 23. But it's taking the shape of solar cycle 21, which is interesting. And it also tells me we still have a little ways to go with this solar max for solar cycle 25.
But by no means is this cycle at all a large solar cycle. No. If you go back and look at solar cycle 23, take a look at this. X40 plus, X28, X24, X24, X20. That's all in one solar cycle.
Yeah.
And we're seeing nothing like this in this cycle.
And there's far more sunspots in solar cycle 23, 22, 21 in increasing order.
Yeah. So we're still in a very weak set of solar cycles. And the supposition is that it might get very interesting here moving into solar cycle 26.
Well, I think the biggest factor of interest will be this factor of our weakening magnetosphere, right? Which is due to two things. It's a weakened magnetic field where the poles of Earth are less strong or less polarized than they have been in the past. And it is also sort of this ongoing decrease in solar activity, which tends to trigger our magnetosphere. The solar activity does. So when the solar activity decreases, our magnetosphere over the long run decreases. So you throw that together, and it's like while the solar cycles, the maximums may be less intense, the potential for their effect on us and our infrastructure is higher because of the weakened magnetosphere.
Yes, agreed. Now let's take a look at this X40 back in solar cycle 23. That got up to an R5 radio blackout. And guess what? We're all still here.
Yeah.
So that gives you some idea of what we're looking for, something larger than that for a grid down scenario. And we're nowhere near that in this current solar cycle. So that's really good news. We've got a weak sun. The bad news is we've got a weak magnetosphere. So if we do have an X40, it might have more effect than that X40 back a few decades ago.
Yeah. Yeah. And would you also agree that some of this in part depends on, whether or not there is a CME along with the solar flare and the duration of the CME's effect on us? Like the longer we are in geomagnetic storm, the more danger our infrastructure is in. Would you agree with that?
Right. And the only bad scenarios are when you have multiple X flares, one after another, and you get cannibalizing CMEs. So you get plasma that stacks up on itself. That's when the big effects can happen. A single large flare with a CME, I don't think is a knockout blow, unless it's like a 10-hour continuous long duration, high magnitude X flare. But we really haven't seen anything like that since we've been watching the sun. What we do see is like the superstorm back in May. Certain sunspots will blast out CME after CME, and then that's when we get into that danger zone.
Yeah. Well, and do we know if, let's say, the Carrington event, was that a long duration X flare?
It was multiple. The geomagnetic storm lasted for days, so that had to be multiple CMEs.
Yeah. Yeah.
Yep. I mean, we didn't have any readings then. We just know that it lasted for days, and the only way that's happening is if there were multiple flares.
Right. So we can just reason backwards on that. I mean, that's not to say that, some of these less intense X flares can't cause some effect, right? Like I mentioned these X flares to my family, and my sister informed me that in Australia, her and her husband's house suffered a power surge and it fried their internet router, probably right about the time of the X7.1. So that was interesting. I mean, that may not be the reason why.
No, I don't think though. So because that's just going to cause a radio blackout during the flare. It would have to be the arrival of the plasma entering our ionosphere, charging the Earth to fry that.
Yeah. Yeah.
Now here's the bad news. All right. Geomagnetic storms charge the weather. And this hurricane is going to be forming the next 2 days. So the likelihood of this being extremely strong is very high because we're about to go into geomagnetic storm tonight, and it could last for days.
Yeah.
All the way up almost until landfall. So all this energy could be pouring into those systems.
And it ain't HARP.
No, thank you for saying that. These hurricanes are normal. They're not being formed by antenna that produce less than 1 megawatt of energy in the Arctic, right? And so
I really wish there was some understanding of that context out there, the extreme lack of power of HARP, and so therefore its sheer inability to have any major effect just based on lack of power. Again, as always, the power of the sun outweighs anything we've ever done.
Yeah, the energy in this incoming geomagnetic storm is probably equivalent to like 1,000,000 nuclear explosions.
Well, that's what I was going to say. I wish I knew what an estimate compared to, in like megatons of a bomb, like how does that
Or the
compare?
voltage, it's probably like terawatts of energy per square foot.
Yeah.
As opposed to 1 megawatt in HARP. Like a small turbine on a river.
Right.
Oh, yeah. So this could be a supercharged storm thanks to the sun.
Yeah. Thank you, son.
Anything else you want to discuss on the topic of the geomagnetic storm incoming or the hurricane?
Nope.
All right. Well, that brings us to the next topic. And that is the 2 billion-year-old rock found harboring microbes, and they're still alive. Crazy. The ancient organisms could help us understand the origins of life on Earth and may also aid in the search for life on other planets. Because what this means is these microbes are living in their own microbiome. They're sealed in these rocks, and they can remain there for billions of years, eating off of the clay minerals.
Mm-hmm.
It's literally like a mini universe to them. And so that means that if any planet ever harbored life, and then the surface was stripped of its oxygen or what have you, like Mars,
Mm-hmm.
if you were to drill down into the rocks, you would probably find microbial life.
Yeah. And in fact, the authors of the paper that inspired this press release or article, they're very excited to get any rocks coming back from Mars, from I forget what the spacecraft is called, to see if they find any of these microbes, and that's really fascinating. I mean, the other thing that's really fascinating about this too is, this paper notes that these microbes that they found, their evolution is extraordinarily slow, and so is their metabolism, like wildly slow. So,
well, that would make 100% sense because they're trapped in this environment that does not change at all.
Yeah.
It's fascinating. It's like freeze framing a day on Earth, and it never and that's it. It never changes.
Well, and that's one of the great interests that the authors have in this is there's some potential to use these microbes to get a better picture of life on Earth 2 billion years ago. I mean, that's a fascinating prospect.
And is there any danger to
Right.
exposing these to the current environment?
Right.
That's a big question.
Yeah,
Go ahead.
Well, maybe we should back up a little bit and give a little background on what they did here.
Yeah, let's go. Let's do that. But before we do that, what we're going to share with you is the IFL Science article. And then there's a press release from the University of Tokyo.
Mm-hmm.
And then we're going to share you the paper. But I have to warn you, the article from IFL Science is hilarious. And I don't know if you caught this. At the end, this is what they say. While Martian rocks are generally much older, 20 billion to 30 billion years old, NASA's Mars rover Perseverance is currently due to bring back rocks that are a similar age to those used in the study, and that would be 2 billion years old. Now, did you catch the amazing error there?
Well,
our solar system is only 8 billion years old.
Yeah, so I'm really confused by that statement.
So how can Martian rocks be 20 to 30 billion years old when they claim that the universe is only 18 billion years old?
It's so weird. Like, what a giant error to make in writing this article.
You're right. The current consensus on the age of Mars is 4.6 billion.
That's so weird.
So IFL Science has got to do some better fact checking.
Well, that's funny too, because look, the writer of the article is also an editor. Oops.
Good catch. Good job, Maddie Chapman.
Yeah, that's some
So
bad science. There's a lot of bad science writing out there, I will say
that
that.
means that this woman doesn't know how old the consensus is on the age of the universe, let alone Mars.
No, I mean, she probably doesn't know much about any particular field of science. She's just doing science writing. And so every time she sits down to write an article, she's got to, dig a little bit for a bit of background information, but she doesn't know any of it, so she's not filtering it correctly, and she's not catching misleading errors. But anyway.
Yeah, where did I just go? How did I get here?
Yeah.
All right, the press release, a 2 billion-year-old rock home to living microbes. Absolutely fascinating. And it says here in the first paragraph, I'll read that, and then if you want, you can probably walk us through the study.
Mm-hmm.
Pockets of microbes have been found living within a sealed fracture in a 2 billion-year-old rock. The rock was excavated from the Bushveld Igneous Complex in South Africa, an area known for rich ore deposits. This is the oldest example of living microbes being found within ancient rock so far discovered. The team involved in this study built on its previous work to perfect a technique involving 3 types of imaging, including infrared spectroscopy, electron microscopy, and fluorescent microscopy. And this is to confirm that the microbes are indigenous to the ancient core sample and not caused by the drilling itself.
Mm-hmm.
So, fascinating. Now, I was
Yeah.
a little skeptical, but first, before you go over the paper, the Bushveld Igneous Complex is the largest layered igneous intrusion in the Earth's crust. It's tilted now, 2 billion years later, and eroded, and it forms outcrops at what appears to be the edge of a great geological basin referred to as the Transvaal Basin. And so there's your background there. And so let's talk about the paper. Subsurface microbial colonization at mineral-filled veins in 2 billion-year-old mafic rock from the Bushveld Igneous Complex, South Africa. Whew.
Yeah. I mean, I'm not going to get into a huge amount of detail here because it's a bit technical as far as the techniques that they used. But as you mentioned, they used infrared spectroscopy, electron microscopy, and why is that so hard to say? And fluorescent microscopy. They did a very good job of checking, well, keeping the environment really sterile. Like, okay, this picture is a great example of something that they did in order to keep. So this is a core sample that they took. And they made a point of keeping it extremely clean. They washed it with highly filtered water. They flamed the outside of the core to, remove any remnants of other modern bacteria from the surface. And then they vacuum sealed it and then they froze it.
Vacuum sealed with an oxygen remover.
Yeah, that too.
Yeah. And then it was stored at 4 degrees C.
Yeah.
Super stable.
So, I mean, this process was a bit different than other things that have been done. And I think maybe they did do this somewhat where you're kind of not grinding up, but you're kind of breaking up the rock and trying to extract the microbes that way. This is different in the sense that they're just trying to visualize it without disturbing the rock itself and to keep all of the fractures and veins sealed as they are. The veins are sealed by clay minerals, as you mentioned earlier, like fully and completely sealed. And so they did some things to verify that that those seals weren't breached in any way. So they were really careful about contamination, which I really appreciate. And then they did things like they compared the spectroscopy of known bacteria to what's in there, stuff like that. So they have good evidence of the microbes that the microbes are in there, that they have not been disturbed or contaminated, they're sealed, and the rock itself is 2 billion years old. So that tells you that those microbes have been in there a very long time, which is fascinating. And as I mentioned earlier, um, these microbes, their metabolic rate is tremendously slow. So it's like life in slow motion. And I think on some level that does translate. I think maybe I'm wrong, but maybe you could look at the caption. I think this bee image, I think this might actually be the DNA lit up here, with fluorescence.
It says visualization of the microbial cells
Okay,
after
no, this is the staining.
green staining.
Yes.
This is fluorescence, microscopic images of the area of the section highlighted by the orange rectangle.
Yeah. So,
Yeah.
I mean, I assume that a tremendously slow metabolic rate would translate into slow evolution at some point. So that's really interesting too. And as you mentioned, it's like, well, would there be a danger in exposing these microbes to the current climate, or vice versa, exposing the current climate, I mean, our current environment, to these microbes? Personally, I think the answer is no, but it's an interesting question. And I think it raises a lot of other questions that we've talked about before. Let's say about the idea of panspermia, right? Like, we've talked about the idea that we may get biological material from space, that there may actually be biological material in comets, in asteroids, that some of this material at some point ends up on Earth, which is a little hard to wrap your brain around. But then if you look at some of the experiments that have been done with certain microbes, let's say even on the exterior of like space shuttles that survive, and it's not just that they're in space and surviving, but they're surviving coming through our atmosphere, which is insane, right? I mean, things get lit on fire coming through the atmosphere, but yet that can still happen. So what's so fascinating to me is, like, we're talking about 2 billion-year-old rocks that have encased and sealed inside them these microbes. Like, who knows where those came from?
Yeah,
Like,
they came from the Earth 2 billion years ago.
right, but given that given
The
that they're
question is,
sealed,
how did they get to Earth?
how
2
did they
billion
get
years ago?
there?
Yeah.
Right. And where, and then if you think about that in the context of the formation of our planet and our solar system, it does seem to blur the lines between what is extraterrestrial and what is terrestrial.
Right. And here's another interesting note. So these are part of the prokaryotic biomass on Earth.
Yes, I was
These
going to mention that.
microbes.
Yeah.
And the majority of the biomass on Earth is contained within the Earth. Most people don't know that.
Mm-hmm.
The majority of prokaryotic life is contained within the first 30 meters of Earth, which means that there are billions of bacteria and microbes underneath of our feet, in the rocks, in the soil. And some of them have been stuck in the rocks for 2 billion years. It's incredible.
Well, and the other thing about that, prokaryotic, by the way, means a microbe that doesn't have a nucleus, doesn't have a membrane enclosed nucleus, versus eukaryotic, which does. And prokaryotic life precedes eukaryotic life.
Yeah.
So that tells you I mean, it gives you another just feeling about the age of these microbes and how long they've been around. These types of microbes, anyway. So,
right,
and
dangers to humans come from eukaryotic life.
Right.
In the form of anything. Just think of like leeches and piranhas. So any animal, anything that has a nucleus can be anything other than one of these prokaryotes. And that can include, and there are some things like viruses that aren't even on this.
Sure.
Right?
Sure.
And so I think that the prokaryotic life that's 2 billion years old is zero threat to Earth for a number of reasons. It's so primitive. that it doesn't really do anything. It feeds on like basic minerals. Yeah, it's not really doing anything. It usually has a beneficial effect because these microbes are allowing plants to grow, let's say, in the subsurface by exchanging minerals for them at the root.
Yeah.
So these are very important to life on Earth, and I don't think a danger. What
Well-
is a danger is starting to reanimate ancient eukaryotic life, like
Potentially.
reanimating woolly mammoths.
Potentially.
Yeah, and this is happening. This paper I talked about yesterday, it's been in the news for 3 years. This company is claiming that they are about to unveil a woolly mammoth before 2028. That's 3 years from now. Isn't that crazy?
What are they going to do? Keep it in a zoo? I mean, like,
No, they own a whole island like in Siberia where they're doing this. It's just like Jurassic Park. Because what they want to do is create herds of these and release them up in the tundra as part of their climate change effort.
because that's somehow going to stop climate change?
Right. The herds of large animals like this sequester carbon by eating all the grasslands and trampling the ground, right? It creates a more fertile environment. And if you grow more tundra grasses, you essentially lock up more carbon in the grasses, right? So that's the idea here, to save the planet with woolly mammoths.
Backing
But
up
not
to
going to stop there. They're going to try to fake some dinosaurs or saber-toothed cats or more recent animals that are very dangerous to humans.
Yeah, I mean, there's definitely always this temptation of kind of like playing God. It's the same thing, when we cloned Dolly the sheep and all of that stuff. Like, I find cloning animals and messing around with CRISPR, I find very it gives me the ick, like at a very basic instinctual level, like we shouldn't be doing this stuff. Nor should we be, well, I won't go there right now. So we don't get demonetized. But going back to the
speaking of demonetized, the last video we did was demonetized, the Permian extinction, but they remonetized it a day ago after everyone watched it.
6 days later. So you got cheated on your revenue, and they really should be forced to reimburse you for that, but they won't, of course.
No, that will never happen.
So going back to the prokaryotic microbes and their existence, trapped in these rocks. I mean, the other thing that it made me start thinking about was, and the other reason why I would say I really don't believe that these are of any danger to us is, like, given, let's say, geological instability in certain parts of the world where there are volcanoes and earthquakes, obviously when those things happen, if there are pockets of microbes, they're going to be released in those events. So that's something else interesting to think about. Also, kind of from the panspermia perspective as well. I was kind of thinking about expanding Earth hypothesis while I was thinking about this. And, let's say we have parts of the Earth where we have an expanding crust and pockets of microbes like this are released during events like that, or just during regular volcanoes, earthquakes, whatever. I mean, we have a constantly changing Earth and a constantly changing crust that contains these pockets of these microbes, which is really interesting to think about how that can then potentially affect all life on Earth. And maybe it's not just prokaryotic microorganisms that are trapped in rocks. I mean, maybe there are other kinds of microbes trapped in rocks that will have some effect on us.
Right. Here is another. Let's take a deep dive. The question is, how did these microbes get on Earth 2 billion years ago? The bigger question is, this is the Bushveld igneous complex, okay? It is the largest layered igneous intrusion. Do you know what that is?
Sort of.
An intrusion is when you push volcanic rocks from deep in the earth up into the crust.
Right,
and
right.
it doesn't get to the surface. So it can squeeze out between like sedimentary layers into what they call a sill, which is flat and lateral. But here's the question. If this igneous material, the largest intrusive complex known, is coming from deep in the mantle and being emplaced in the crust, never gets to the surface.
Yeah.
Why are there living things in it?
Right.
Is it spontaneous during the cooling process?
Right.
These are big questions.
Right. So
which
fascinating.
Means life is coming from the center of the earth in some instances.
Well, right. And if you were to believe, and I don't, but if you were to believe, let's say, in the like accretion model idea of like the formation of a planet or a solar system, then all of this material is coming from somewhere else.
Right. It would be remnants of the initial gas cloud that was our solar system.
Yeah.
That idea should be so easy to debunk. The different types of terrestrial and gas giant and planets that we have, there is no conceivable way that could occur. And their explanation is a literal fairy tale.
I just watched yesterday a video about Pluto, and I'm forgetting the spacecraft that got some really awesome pictures of Pluto and its moons. I think this was, when did the photos come in? Those photos, I guess, really came in a few years ago. It took a long time to get the data here.
Yeah, they're covered in glaciers, in ice. It's so bizarre.
Yeah, like Pluto seems to be covered in like a nitrogen ice largely, and its moon Charon, probably water ice. But so after the craft did all these photographs of Pluto, the craft was still functioning. So they're like, okay, we got to check out something else. So it goes and checks out. I'm forgetting the name of it right now. It's like an significantly sized asteroid body in the Kuiper Belt.
Ceres.
No, it begins with an A. Shoot, I wish I could remember the name of it.
Ceres recently they imaged it and it's got water on it and it's an asteroid.
That's not what I'm talking about. So this other object is it's interesting because it looks like a dead comet. You know how we see a lot of comets that have that like dumbbell shape?
Yeah.
It has that shape. And so they're trying to hypothesize about why it looks like that. And they seem to be very keen on suggesting that these are really like two separate rocks that somehow melded together. And it just sounds so asinine. It's like a hypothesis that a 5-year-old would suggest.
That shape, it's been confirmed through Electric Universe that it's electrical scouring.
Yeah. I think that's what this object is. I think it's a dead comet that lost its charge somehow, and it's just floating now. So it probably was an active comet. It was scouring, which is why it got the dumbbell shape, and now it's just sitting there. But this idea that these two rocks
it probably has no ice on it either.
I think they did detect some ice, interestingly. Not a lot, but it's not a snowball. I mean, we have pictures of it. It's a freaking rock, like all the other comets that we've had pictures of and the ones that we've landed on. They're rocks. Anyway, but the idea that you can just take two rocks and somehow they just somehow get stuck together and then meld is so ridiculous to me. Like, what are they, sticky or something? It's just, and they claim that what initially happens is they're tidally locked, and so because they're like touching each other, then they eventually meld. And it's like, when do two rocks ever meld together? Like, what is the geochemical process that causes that? Like, I don't know that there is one. Maybe I'm wrong, but it just sounds ridiculous to me.
And it feels on purpose. I mean, people at the top of cosmology cannot be this dumb.
Well, that's the thing that's so perplexing about this. And they don't say that that's definitely what happened. I think they proposed like two other theories. But the impression I got was that was the reigning theory. And I'm like, really?
Yeah,
It's
because the more of these objects we'd see dumbbell shaped, you need to come up with a new hypothesis.
yes.
Something else is
Yes.
going on.
Yeah. Yep. And you should easily be able to take note of all of the comets that we know of that have dumbbell shaped, and then maybe that should make you go, I wonder if there's a connection here with these dumbbell shaped rocks, that it's not random, that there's a reason for it.
Yeah, absolutely.
It's interesting.
So I'm still baffled about how microbes get inside lava.
Yeah.
Because the
But
lava
how are they surviving like the interior of the earth, right? Like how is that happening?
they have to come up in the molten lava.
Right.
So this is 2,000-degree stuff that gets put into the subsurface of the earth and cools there.
Yep.
So they could, I guess, travel through a crack in the cooling lava to get to their pocket, but it's still cooling lava. It's just insane to think how is this happening?
Well, in a way, it's sort of a similar question to how is it that we have run experiments with microbes that are surviving re-entry into Earth's atmosphere? Like,
Yeah.
how is that happening? How is the DNA not getting destroyed?
Right. We just unfroze. How old was it? The parasite.
I'm sorry, I'm not remembering what you're talking
The
about.
last show we did, they just found a complex organism in the permafrost that they thought it's alive.
Right.
That was what was it? It was some type of a
Are you
parasite.
talking about the nematode?
The nematodes, yeah.
Yeah.
How
Yeah,
old?
not a parasite, a nematode. That's why I got lost there.
How old were they?
I don't remember. Very old.
But
They
extremely
reanimated
old.
it. Not only did it reanimate, but they now have it somewhere, I guess, in a lab reproducing. And this again raises this question of like, is this safe to reintroduce a nematode that has been, I want to say it was like 40 million years or something, but I could be totally wrong there. How is
Well,
that
it
safe
eclipses. So the oldest tardigrade we found and
Mhm.
reanimated is like 600 years old. That's it. This thing is tens of thousands of what I remember. It was, and
Yeah.
it's spooky.
Yeah. But maybe this does partially answer the question about how dangerous, let's say, is it to revive creatures that have long been dead or have been buried, and maybe the answer is it isn't really that dangerous, but maybe it depends on the creature itself. I mean,
Yeah, we have far more dangerous things on Earth in BL4 labs,
yeah,
right?
yes.
We just had the whole Wu flu, and who
Mhm.
knows what else they're creating in those labs.
If you ever want to get really terrified, I don't remember the author, but go read the book The Hot Zone. It's all about like however the levels are numbered, level 4 biolabs that work with extremely dangerous viruses like Ebola, etc. The whole book is about really dangerous viruses like that, and it's absolutely terrifying.
Oh, here we go. Live on air. The BZ just shot south. I can
Oh,
see the speed
yeah,
going up. So
yeah,
it's probably happening right now, which means it's a little early,
yeah.
but a good chance for aurora as soon as the sun sets.
Yeah, yeah, cool.
Yeah.
So, I don't know, the fact that we have these organisms living in 2 billion-year-old rocks that, could easily be brought back into our environment either on purpose or just through natural events. I mean, it tells you something that also about, we have this very linear picture of evolution, which can't really be true, right? If an earthquake is going to release some of these microbes into the environment again, then, there is a repeating or cyclical effect of evolution in some way,
Absolutely.
you know?
Absolutely. We have to have ways to get across mass extinction boundaries.
Hmm.
We have to have ways to colonize new celestial bodies.
Hmm. Well,
So, yeah.
and then, I mean, isn't it interesting that, we've looked at the Permian mass extinction, we've looked at other major mass extinctions before, and it's typically what happens, you have a mass extinction, and then the next thing that happens is you have all these other different forms of life that show up because the conditions have changed, and now the material for those organisms, which is apparently already there, has the opportunity to flourish. And so maybe that is part of this recycling process. And it's almost as if, like with these microbes, it's like the earth is storing biological material for future use in a way, And like you said earlier, tiny microorganisms have an effect on all of the other life on earth because there's a food chain and somebody is going to be eating that at some point and providing minerals to plants, and then some other animal is going to eat the plants, and so it just goes round and round and round. I mean,
yeah, and then a big comet comes in and smashes the surface of your planet and blasts some of the crust into space with these microbes, and then they land on other planets.
Yeah, I really feel at this point that there isn't really any distinction between terrestrial and extraterrestrial. There is in any given temporal moment. Right now at this moment, there are things that are life forms that are terrestrial and probably those that are not, but overall, it's all the same. It's not just stuff coming from Earth.
None of it is.
Yeah.
Everything comes from the local star. Every single atom on Earth came from the sun. People don't get that. They understand
well, and some
that
of
we
it
are
comes from
stardust.
farther away than that too,
Well,
right?
We get
we get ions in cosmic rays that are from much further away than the sun.
Yeah, everything on Earth is alien, even though it's here.
Yeah. Well, and as we've discussed before too, I mean, there's evidence potentially of biological life, let's say in comets, right? There's analysis that has been done that shows, like, I can't remember what, I think it was a comet that was actually emitting ethanol, right? Alcohol. That's a product of fermentation, which is an organic process. That's fascinating. Like,
right,
what is going on out there?
Yeah, all the oil and gas is being manufactured in the earth and is rising up. It doesn't have to do with dead dinosaurs or fossil forests. That's completely insane.
Well, I was wondering about that
too. Coal is compressed forests.
Yeah.
Yeah.
Right.
But hydrocarbons don't come from coal.
Right. Well, that
is a hydrocarbon.
This paper made me start thinking too about abiotic oil and, like, are these microorganisms potentially playing a role in the production of oil, or could certain microorganisms be doing that?
Very deep that we can't drill to and know anything about.
Yeah.
This is becoming clear. So now what this means is if we were to take a chunk of this granite, the Bushveld igneous complex, and blast it into space, within the rock, there would be a self-contained colony of microbes floating around for up to 2 billion years before it gets anywhere.
Yeah.
And when it gets there and hits, it may crack the rock open and expose those microbes to the surface.
And vice versa, there may be a very similar thing going on comets, and then maybe we have pieces of comets that crash into Earth and introduce something new.
But how are the microbes are being created within the mantle?
Well, right. And so
that is the question.
Right. I mean, there's a big, that part, that's the really confusing part of this. But again, we've seen evidence that microbes can survive some really extreme conditions, which I don't understand. Especially when it comes to heat, right? Like, freezing and ice, I get. You can preserve a lot of things in freezing conditions. There's a lot of things that can just basically go dormant. And I'll just give us, two silly examples, that are earth-based. If you're familiar with kefir, which is a sort of bacterial yeast symbiotic relationship that makes like a type of yogurt out of milk, you can take those kefir grains and just freeze them and take them out whenever you want and thaw them, and you can have active kefir cultures again. Same thing with sourdough. The yeast in sourdough, you can freeze it and thaw it, and it's good again. So, like, in that respect, from the preservation perspective, it makes some sense because you can send those organisms into such a slow metabolic state that they just kind of go into stasis. But the heat and the fire and the magma, I don't get that. Like, how are microorganisms surviving re-entry into Earth's atmosphere or surviving lava? Like, how is that happening?
How did they get in there?
Right. Well, I mean, maybe,
Goodness.
maybe the microorganisms got into the veins and the fractures of these igneous rocks after they cooled.
Yes, let's pray that that's what's happening.
Find us tonight on Magnetic Reversal News at 8 p.m. Mountain Time on YouTube.
Listen to Revolution Radio at freedomslips.com. And we'll be right back after this message.